Okay, so this is standard 7, potential and kinetic energy. Just need to remember that kinetic energy is motion energy. No, object is in motion, the measurement of that. And potential energy is what they call gravitational energy. So when you hold an object up high, you're giving it potential energy, and then when you drop it, it's converting from potential to kinetic energy. And at the end of the drop, there's no more potential energy. It's all been converted to kinetic energy. So the more speed, so we had a lot of the proportional laws on this one. The relationship between the independent variable and the dependent variable. So we're going to abbreviate. We're going to say potential energy is PE and kinetic energy is KE. So we said these are the laws. The more speed, meaning that's the independent variable, right? The more speed, the greater the kinetic energy. So basically we could have two arrows here. More speed, more kinetic energy. And then same is true with mass. As mass increases, so does KE. So basically what we have here is a proportional relationship. That's a general law. So specifics would be when like a wrecking ball is larger in mass, then it's going to have greater kinetic energy, or it's going to move, it's going to break down a building faster, move the wall of a building further because of its kinetic energy. Okay, and then that's kinetic energy, and then we have a few laws for potential energy. So the greater the potential energy, and from gravitational energy, the greater the kinetic energy. So when objects fall to Earth, right? So the higher they are, the higher they start, the more kinetic energy they're going to have. The greater the height an object is from the ground, which is the potential energy, the greater the kinetic energy. So kinetic energy is a measurement of when the object is already in motion. So it doesn't subtract or the energy needed to get the object in motion from rest. So we all know that something that has more mass, it's going to take more energy to get that object in motion. But what we're measuring for kinetic energy is when it's already in motion, it has a lot more energy than something that doesn't have as much mass. So let's say that there's a truck moving down the highway. It's already in motion. It's already going top speed. And if it hits a car, it's going to do a lot more damage to that car than, let's say, a motorcycle moving down at the same speed and hitting the same car, because that motorcycle doesn't have as much mass, and so there's not going to be as much energy. Okay. So that can mix you up, because you're thinking, okay, an object at greater mass, that's going to be slowing down a lot. But you just got to think of it just in motion. It's going to have more kinetic energy. So whenever you add more mass to an object, you are increasing its kinetic energy. You also can increase kinetic energy by reducing friction. So you can oil something to reduce friction. You can add wheels to something to reduce it. There's just lots of things you can do to reduce friction, but whenever you do, you're increasing kinetic energy. So we're talking laws here. This would be, when we reduce friction, we increase kinetic energy. So again, this would be the independent variable, and that would be the dependent variable. Another way to increase kinetic energy is to add more force. And you can add force to a moving object by, with engines, like fossil fuels, burning fossil fuels for engines, and you're adding more force to something, or you can just add your own muscle strength to it. Throw something harder, that's going to increase kinetic energy. Also, if you add more potential energy. Oops, let's just erase that. And we already know that. Add potential energy. Okay, you increase the height that you drop an object from. So that increases kinetic energy. Okay, so for potential energy, there's a few different ways to have potential energy. And I think we mainly talked about two. We may have mentioned one of the other ones, but we didn't talk about the last one. So this is gravitational. We've already talked about that just a few minutes ago. But then we have elastic. So this would be like with a rubber band. The farther you stretch it, the more elastic potential energy it has. Or with springs, like on a trampoline. The farther you stretch a spring, the more potential energy it has. Okay, the other potential energy forms are like gas, fossil fuels. So they basically have energy in them. So if we burn them, then they will create kinetic energy. And the other one is food. So when we use that creates energy. We know that from photosynthesis, C6H12O6, that has energy, and atoms having energy in their bonds. So when those bonds are broken, then energy is released. That's how food, and specifically calories of food, that's another source of potential energy. Different kind than gravitational. Okay, I like this last part. Okay, so potential, let's just do this. PE is converted into KE, kinetic energy, when an object falls to the earth. So kinetic energy in the object, when it falls down to the earth, kinetic energy is converted into like heat energy through friction when it hits the ground, or it is converted to another object and makes that other object move. And when we have various objects hitting each other and causing other objects to move, that is called mechanical energy. So one object is receiving energy it collides with another object, it acts as a force upon that other object, creates the movement in that object, and so on. And we see that that's, a form of mechanical wave energy also, which is coming up here pretty soon. Okay, so that is that standard 7, potential energy. Wait, let me see. Transferred back and forth. Oh, shoot. A little bit more. Okay, so between kinetic energy and potential energy, these things can be converted back and forth. Like with Newton's cradle, that little thing where you pull the marble up and you let it go, and then it hits this side, and the rest of the marbles receive that energy. That's like that mechanical energy, right? And it makes this side go up and increase the potential energy there, and go back down and hit those marbles again and back up, and it goes back and forth like that. And when you're bouncing on a trampoline, what you got going is elastic potential energy below you, and then gravitational potential energy above. So, and then between here is kinetic energy. So as you're bouncing on here, it's like a closed system where the energy is not reducing. And so you could like just keep going forever, because once you bounce, you come up and you gain the, sorry, that was the wrong word, potential energy. You gain the potential energy, and then it's converted kinetic energy, and down here, and then hit the trampoline, and you're stretching out those springs, and then it bounces you back up, right? That's potential energy until it bounces you back up, converts to kinetic energy, and back into gravitational energy. So in this system, if we increase your weight in this system, then there will be more energy required to increase your potential energy, more energy to get up again to the gravitational height that you did before. So that is going to reduce the total net energy that this system is producing. So if this person is a heavier person is, here, that person is going to reduce the total energy in the system. You're going to have more energy than that person is, because that person's heavier. Also, if you start, if you don't jump as high, if you lower the potential energy, and you only jump a little bit up here, then the same thing will happen. It will lower the total net energy of this system. And the last thing too is this trampoline. If it is not so elastic and instead it increases in tension, then that is also going to take the energy away from the system, because you don't have your spring as much, right? You're decreasing the elastic potential energy, because when tension increases, elastic potential energy decreases. So the total energy in the system is decreasing. Okay, so I think basically that's transferring energy back and forth, and then you see those variables that are going to, be our independent variables to decrease the energy in the whole system. Meaning you decrease the gravitational potential energy by not going as high. You increase the mass of an individual in that system. That's going to decrease it. So in this case, mass is going to decrease kinetic energy. And then also if you decrease the elastic potential energy by increasing the tension of the trampoline, that will also decrease the total energy in the system. And that is the end of Standard 7.